Hey guys, so today we're going to do long division, then synthetic division, and the remainder theorem. Long division hopefully sounds familiar, and we're going to do a practice problem with long division of what we used to do like in elementary, okay? So an expression of f of x equals p of x over q of x, really fractions, right? Those are quotients. Quotients are division, okay? So keep in mind that p of x will be divided by q of x. So the division of polynomials uses real numbers, so on and so forth, right? So let's do a little reminder. What is long division? Well, if you remember the rules, we want to divide, which is actually asking yourself how many. Then we multiply, we subtract, we bring down, and we do all that over again until we have our remainder, if there's a remainder at all. Okay, so right now what we would do is we would say 23. So how many 23s go into 3? Well, none. So let's go to the next one. 23. How many 23s are in 33? Well, there is 1. Now we multiply. 23 times 1 is 23. Our next step is we subtract. So 33 minus 23 is 10, right? We bring down the 5. So how many 23s are in 105? Well, sometimes we have to guess at this. If I said 5, well, 5 times 3 is 15. 5 times 2 is 10. Bring down. So 5 is too many. Of course, you can use your calculator if you need to do so. So let's do 4. Okay, so I'm going to put 4 there. Now I'm going to multiply 23 times 4. Well, 4 times 3 is 2. 12. Carry the 1. 4 times 2 is 8 plus 1 is 9. Okay, now again we subtract. 5 minus 2 is 3. 10 minus 9 is 1. 13. It's lower than 23. So of course we know we did it correct. And in the past, when you first learned long division, you had a remainder 13. Then we got a little bit more sophisticated, and some of your teachers were like, well, instead of having a remainder, what we're going to do is put that remainder over what we divided by. So that would be 14 and 13 over 23. Okay, so that's what we did in elementary. That's what my son is doing. So now what we're going to do actually is do it with polynomials. We know that polynomials have variables. So yes, we're going to have those letters in there. So let's go through this example to show you what to do. So here we have our rational expression. We have 4x squared plus 3x minus 5 divided by x plus 2. Okay, so your divisor goes outside here. Okay, and this goes in here. Okay, now we're going to take the same steps we did above. So what do you need, or how many do you need to multiply to get to 4x squared? So I look at this first term here and I say, how can I make x look like 4x squared? Okay, so what you say to yourself is, oh, if I go x times 4x, that would give me 4x squared. Okay, so then we put the 4x up there. Then we multiply. Remember, multiply. I've got to multiply by both. So 4x times x is 4x squared. 4x times 2 is 8x. There's our multiplication. You want these two to match. If they don't match, that means you have to multiply by something else. That this is wrong. Okay, so now that you multiply, now you need to subtract straight down. Okay, this is where some of you might get tricky. As you can see in our example, we have minus parentheses 4x squared plus 8 because we're subtracting this and this. So what I like doing at one point is actually just changing the signs and then adding straight down. Okay. So of course, these two cancel. That was the point. These two cancel. And then 3x minus 8x is negative 5x. 3 minus 8 is negative 5. And then we bring down this minus 5. Okay, now we're going to repeat the process. But we're going to look at this down here. So remember how many, or what do I do to make it look like? So x times what is negative 5x? Again, x times what is negative 5x? Well, of course, it's negative 5. Then I put that on top and I multiply again. Negative 5 times x is negative 5x. Negative 5 times 2 is negative 10. Now I'm going to subtract, but what I'm going to do is distribute. So I add, so it just looks a little bit better. Now I add straight down. These two cancel. That was the whole purpose. And then negative 5 plus 10 is 5. So we have a remainder of 5. Okay. Now, when we write our answer, some of your questions might ask for the remainder. Some of it might want it in a quotient form. So as you can see, this was our question right here. And when we did the long division, the stuff on top is right here. And then we have our remainder over what we were dividing by. Okay, our quotient is the 4x minus 5. The remainder is 5. Okay, the question should be specific on your homework of what they want for your answer. So let's do some of these together. Okay, so of course I'm going to set this up. What I'm dividing by goes on the outside. I have 2x squared minus 5x minus 12. Now again, I ask myself, what do I multiply x by to get to 2x squared? Well, that would be 2x. And I can double check by going 2x times x is 2x squared. And I got to multiply all of it though. 2x times negative 4 is negative 8x. I have to subtract the whole thing. So what I'm going to do is I'm just going to change the signs. This becomes a negative, this becomes a positive, and then I add straight down. These cancel. That was the whole point. Negative 5 plus 8 is 3x. And bring down the minus 12. X times what is 3x? Well, that's 3. You can double check by multiplying. 3 times x is 3x. 3 times negative 4 is negative 12. Okay, now I'm going to subtract straight down. Well, I'm going to subtract. So in other words, change my signs and then add straight down. And what do you know? It cancels. So I have no remainder. So my answer for this long division is just 2x plus 3. Okay. We're going to do it again. This one looks a little bit more complicated, right? Because as you can see, we have a 3x instead of an x. All right, let's set this up. We have 3x plus 2 on the outside there. We have 3x cubed plus 5x squared plus 8x plus 7. Okay. What do we multiply 3x by to make it look like 3x cubed? Well, the 3's are good, right? But x times what is x cubed? X squared. All right, let's multiply. X squared times 3x is 3x cubed. X squared times 2 is 2x squared, a positive 2x. Now I'm going to subtract. So what I'm going to do is change my signs to add straight down. Okay, those two cancel. That's correct. 5 minus 2 is 3x squared, and bring down the 8x. Okay, 3x times what is 3x squared? Well, the 3's are there. We just need to multiply it by an x. 3x times x is 3x squared. 2 times x is 2x. We're going to subtract the whole thing, right? So I'm going to change my signs to add straight down. I hope that makes sense. These cancel, and then 8 minus 2 is 6. Bring down the 7. 3x times what is 6x? Well, 3x times 2 is 6x. So 3x times 2 is 6x. 2 times 2 is 4. Subtract straight down, which means I change the signs. If I change the signs, it means I can add straight down. So these two cancel, and 7 minus 4 is 3. Now I can't do anything, right? Because 3 times what, or 3x times what is 3? I can't multiply. I would have to go backwards. So this is my remainder. So my final answer is x squared plus x plus 2. That's the quotient. Now it's a positive 3. So I'm going to say plus 3, which is my remainder, over what I divided by. Ta-da. Go to the next one. Now, of course, I'm not just going to do examples that repeat the same thing over and over and over. There's going to be some tricks, right? So here is our trick here. We are missing a term. Do you guys see that? I go from x cubed to x. So we're missing a term. Now, when you miss a term there, you actually have to plug it in when you do long division, so it doesn't confuse you, right? So we're dividing by x minus 3, so that goes on the outside. And on the inside here, I'm going to write down 6x cubed. Now I'm missing x squared, right? So what I'm going to do is say plus 0x squared minus 4x plus 7. So when I do this long division, I need to put in that missing term so it doesn't confuse me. Let's do this like we normally do long division. X times what is 6x cubed? Well, that would be 6x squared. Okay, let's multiply. 6x squared times x is 6x cubed. 6x squared times negative 3 is a negative 18x squared. I'm going to subtract, which means I'm going to change the signs and add straight down. This cancels, and then 0 and 18 is 18x squared. Bring down the negative 4x. X times what is 18x squared? Well, that would be 18. Ooh, this is getting complicated. 18x. There we go. 18x squared. Forgot the x there, guys. This would be a negative, let's see, 4. 24, 2, 3, 54. Did I do it right? Okay, I'm going to change my signs to add, which is nice. So I'm going to, that cancels, and that is 50x plus 7. Bring that down. What times x is 50x? Well, that is 50. And then 50 times -3 is -150. Okay, I need to subtract, which means I'm going to change the signs and add straight down, which gives me 157. So the answer to this is 6x squared plus 18x plus 50. That's the quotient. It's positive, so I'm going to do plus 150 is the remainder over 157 over what I divided by, which is x minus 3. Okay, awesome. Let's just do one more example, a little bit more complicated because this is a 3-termed, right? So trinomial. So we can do long division still. Now, where are we going to do long division? Well, long division is good to learn because sometimes you use it in calculus. So good thing to go through. And guys, like I said, we can totally do this because we did long division in elementary. Now, look, I stopped. Why? What's happening? I'm missing an x squared. I'm missing an x term. Don't forget 0. And then I have this minus 2. Okay. 2x squared times what is x to the 4th? X squared. X squared times 2x squared is 2x to the 4th. X squared times x is x cubed. X squared times 1 is x squared. Okay, change the signs to add. Those cancel, and we have negative 2x cubed. And that, so that gives us negative 1x squared. Bring down the x. Okay. Negative 2x squared times what is negative 2x cubed? Well, 2 times negative 1, and then we need an x in there, right? Because negative 1x times 2x squared is negative 2x cubed. Negative 1x times x is negative x squared. Negative x times 1 is a negative x. Okay. Now I'm going to change my signs to be able to add. So these cancel, these cancel, and then I've got 0 plus 1 is 1. Bring down the negative 2. By the way, in the past I've done this. If I want to know that I've changed my signs, I might use a different color, and you guys can do that too. That way I know I changed my signs. Okay. All right. Now, can we make 2x squared into x? No, we can't go backwards. So what we have here for our answer is x squared minus x. That was our quotient. Plus our remainder is x minus 2 all over 2x squared plus x plus 1. Tricky, huh? Okay. You won't have a lot of those, but this is more of a different challenging question. Okay, so this is long division. Well, there's actually another sort of division that is nice, and it's called synthetic. The only problem with synthetic is you can only use it if your leading coefficient is 1. Okay, so as you can see in this example here, what we're going to do is we're going to do with x plus 2. Now, did we do that? Yeah, we did. This is the same example as the one on long division. So you'll see that we'll get the same answer. Okay, so with synthetic, what we're going to do is we take each of the coefficients, or the term in front of the variable, right? And we put them down. So 4, 3, and -5. Don't forget to do the sign with it. Okay. Now on the outside here, what we're going to do is what makes that 0. Okay. So that's why on the side here it says x plus 2 equals 0, and we solve, which of course is -2. And that's what we put in the box. Okay. Then what happens is you take your first value here and you go straight down with it. Okay. So I just put the 4 straight down. Then what I'm going to do is take my value here and say -2 times 4 is -8. And then I'm going to add straight down, which gives me -5. Then I'm going to take -2 times -5, that gives me 10. And then I'm going to add straight down, and that gives me 5. Can you see those numbers? Now, how does that help us? Well, this last term will always be your remainder. The next term will be your constant. And the next term after that will be your x squared, and so on and so forth. And that is why our answer is 4x minus 5, remainder 5. And that's what we got for an answer on the other long division. So again, we can only do this when this binomial is something to the first, leading coefficient of 1. Okay. So again, I take my terms here. So that's 1, -8, and positive 15. Okay. And I have my box value. What makes that 0? X minus 5. What makes that 0? Well, 5. Okay. First term, we bring straight down. Then we multiply. 5 times 1 is 5. Add straight down. -8 plus 5 is -3. 5 times -3 is -15. Add straight down, we have 0. So we have remainder, constant, and x. So our answer to this is 1x, or just x, minus 3. And there's no remainder, right? By the way, when there's no remainder, or the remainder is 0, that means that this binomial here is a factor. So let's keep in mind, no remainder means it is a factor. Okay. Do it again. We can use synthetic because it's x minus 3. Now here, I even have a note for you. Don't forget those missing terms, just like we did in long division. So we have an x cubed, so that's 1. The x squared is -4. The x is 0, and the constant is -5. Okay, see how I put that in? What makes this binomial 0? That would be 3. Bring down the first term. So 1. Now let's multiply. 3 times 1 is 3. Add straight down. -4 plus 3 is -1. Let's multiply. 3 times -1 is -3. Add straight down. 3 times -3 is -9. Add straight down. We get -14. Remember, this is remainder, constant. This is x, which means this one's x squared. So our answer is x squared minus x minus 3 minus, because I'm going to put a minus because it's -14. 14 all over, what did we divide by? X minus 3. I don't know about you, but synthetic is a little bit easier. The thing is, like I said, we can only use it in the sense that we have 1x to the first, okay? Otherwise, we have to use long division. You do synthetic a lot in 1050 because we break down big polynomials like this. Imagine if I said to you, hey, here's our polynomial. I want you to factor this. Well, we haven't learned how to do that, but one way to help us find the factors is synthetic division. Okay, let's make sure we're not missing terms, but of course this is gonna be longer, right? So we have 2x to the fifth, 5x to the fourth, negative 2x cubed, 2x squared, negative 2x, and a constant of 3. So we weren't missing any terms. What makes that denominator 0? Well, that would be negative 3. Okay, bring down your first term, so 2. Multiply. Negative 3 times 2 is negative 6. Add straight down, we get negative 1. Negative 3 times negative 1 is 3. Add straight down, we get 1. Negative 3 times 1 is negative 3. Add straight down, we get negative 1. Negative 3 times negative 3 is 3. Add straight down, we get 1. Negative 3 times 1 is negative 3. Add straight down, it's a 0. Hey, if our remainder is 0, what is it again? That means it's a factor. Okay, this is the remainder, so that means this is our constant. This is our x, x squared, x cubed, x to the fourth. So our final answer is 2x to the fourth minus x cubed plus x squared minus x plus 1. And there's no remainder. So that is our answer. Okay. Another thing that's awesome is the remainder theorem. If you just want to know if something is a factor of the polynomial, you can use the remainder theorem to allow you to know if it's a factor or not. Okay. You do this by evaluating on what makes the binomial 0. Okay. Let me repeat that in terms of our example. Okay. So the first thing you're going to do is you're going to take what you're dividing by and say, hey, what makes that 0? So like on A here, what makes this 0? Well, x would have to be negative 5. So what are you going to do? What you're going to do is evaluate at negative 5. So f of negative 5, of course, means to plug in negative 5 for all your x's. Negative 5 minus 5. Now, you can do that in your head. You can do that with your calculator. I am fine with either one. I'm going to use my calculator right now, guys, because I am recording after school, so my brain is kind of shot today. 2 plus 14 times negative 5 minus 5. Okay, did I plug that in right? It looks at enter. And what do you know? I get the value of 0. Now, when I get 0, right, that means yes, it's a factor, because that tells me what the remainder is. The great thing about this is when you plug in, whatever value you get is actually the remainder value. And we know when the remainder value is 0, it is a factor. So again, what makes this 0? 3. Let's plug in 3. So we get 2 times 3 squared minus 7 times 3 minus 4. Okay. So 2 times 3 squared minus 7 times 3 minus 4, and I get -7. So -7 is the remainder, and it is not a factor. Okay, what makes this 0? -2. So let's plug that in. F of -2 equals. So make sure you put your negatives in parentheses, because that will change your answer if you use your calculator. Squared minus 6 times -2 plus 8. I'm going to plug that in. Let's see, parentheses, -2, close parentheses, 2 to the third, minus 3 times -2, close parentheses, squared, minus 6 times -2, close parentheses, plus 8 equals 0. So yes, it is a factor. Okay. Now, one more, of course, we're going to do something that's a little bit more complicated. What makes this 0? If you have to do your math to rearrange it and solve for x, that's fine. We would have 2x equals 5, x equals 5 halves. And we can still do this. So this coefficient does not have to be 1 for us to do the remainder theorem. Okay, it just needs to be a binomial. So let's plug it in. F of 5 halves, right? So we're going to plug in 5 halves for each x. The one thing I like about writing it out like this is that the way I write it out tells me exactly how to type it in my calculator. Okay. So let me see if I can show you a little bit. So 2 times 5 halves squared minus 5 halves minus 10. And what do you know? The answer is 0. So yes, it is a factor. Whew, I know that was a lot. So when you do your practice, make sure you identify, does the directions tell me to use long division or does it tell me to use synthetic? Also, if it doesn't tell you which one to use, you can use whichever one you want as long as it's possible. So remember, for synthetic, it has to be 1x to the first to be able to do this. Otherwise, it gets confusing. You'll learn in higher math in college algebra that yes, it doesn't have to be to the first. It just has to be, or it doesn't have to be 1x to the first. It could be 2x to the first. But I don't know about you, but I don't want to make you do fractions for synthetic right now, okay? Maybe next year. All right, good luck on that practice and ask any questions you need.